The following is an introduction to debugging code in Python. We're going to use several different Python environments today. This includes the idle environment, the Spyder environment, and the iPython notebook. When we go to debugging our code, it's usually best if we don't put any errors in our code. The best way to avoid bugs is to not put them in the first place. Of course, that's obvious, but it's also usually unavoidable. But nevertheless, the more careful you can be when writing your code, the less time you'll have to spend debugging, which can be a time-consuming process. There's three main types of computer bugs. The first are called syntax errors. This would be where you have written something that's illegal for the language. So something like not putting a colon after an if statement in Python, for instance, or not properly indenting your code. These are usually pretty easy to find, and the program will tell you about them. The second are execution errors. This is where you've written correct Python code, but something bad happened during the execution. So suppose you divide by 0 somewhere, or you set one variable to be 0 and then you try to divide by it. The code is correct, but you do something that's illegal, like divide by 0. That's an execution error. And it's also relatively easy to find typically, although the cause of it can sometimes be more challenging. And finally, logic errors are where the code is written correctly in terms of the language, but it doesn't do what you want it to do because you didn't write the correct instructions. And these errors can be fairly challenging to find. I'm going to be using a Mac, but the same behavior works on your machines. If you're working on a Windows machine, you'll want to go to the Start menu to the Math Programs, and then go ahead and open up the Python XY link. And we can choose from a few different options. I'm going to first open idle, and we'll look at debugging and idle. We've seen this before. If we go ahead and click on idle, then we get an editor window here. Let's go ahead and open up a test file. Open, and dbg1, and here's the code for that file. And then suppose we have a problem with this code. We don't necessarily know what it is, but we want to inspect it. So rather than just run the code, we want to be able to interactively inspect the different features of the code. And so that's what we'll use a debugger for. So for instance, if we go to debug and click the debugger, then it drops us into a debug mode and gives us another window here. And we'll click on the source button so that we can step along with the source. Then if we go to run the code, run module, then we can see it starts us at the very beginning and it highlights the line that it happens to be on. And then here we can see a list of all the variables that we declare as we declare them, and we have some options for go. That'll just start running the code, or you can step one point at a time. You can step over something. If you're in, you can step out of something. So for instance, if we go step, if we step on this numpy, it's going to go inside. Let's step over it. Now we're on this line, and we can see if we execute this line, like step for instance, then we can see the variable C1 appears with the value that it currently has. If we step again, we can see C2 appears, then we can go through the line, step, 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 and it adds variables to the local variables that we have. We can turn the locals on and off. We can also do the same thing with global variables, which we don't have any right now. If we step again, we can do this TS, and here that's a function, so we stepped inside of the function. Let's step out of it so that we can get back, get back to where we were. Let's go ahead and quit that. I closed the wrong window. Open. Let's go ahead and open our file again. G1. Okay, and run the module. And we'll go ahead and step over these again. I don't want to go inside the linspace function, so we'll just step over it. And you can see TS is an array, and we can see the different quantities, that the different values that are housed in it. If we want to jump to a specific point in the code, we can set a breakpoint. So let's hit the right. If we right click, we can set a breakpoint. And then we can, if we step over, we're still where we were, but we can go, and that'll run until we hit the breakpoint. So that's an easy way to jump to a particular place in the program. And here we can see I is 1 because we're on the first value of this list that we're looping through. If we hit go repeatedly, it's going to cycle through the loop, and every time it'll land on that breakpoint. But we can see the value of I increasing. So right now it's 2, then 3, 4, 5, 6. And we can see the different values that were defined inside the loop. These flow rate variables here, Q1 and Q2. As we step, as we go, those values will be updated. If we want to get rid of the breakpoint, we can right-click it and clear the breakpoint. We can quit. Simple enough. And if we like, we can go and run it again. Maybe this time we want to put a couple of breakpoints in. One at the top, set breakpoint. One at the bottom, set breakpoint. And when we hit go, it'll run through, stopping where we expect. And we can cycle through sequentially. And this way we can look at the value of our variables as they run and use this as an attempt to debug our code. So that's a way that we can do that with idle. Let's go ahead and look at using the Spyder console. The Spyder is an integrated development environment that has some nice debugging tools, and we'll try that next. So to do that, we can come up and start Spyder, click on the icon that begins it. Now let's go ahead and open a file, and it loads me onto my C drive. I want the J drive where my files are, and I can go down and click that same dbg1, open it up, and here again we see this code. Whoops. We can turn off the breakpoints by double clicking. So in Spyder we get a code window, and then we have some different inspectors for objects, variables, file, explorers, breakpoints, and then this console here. And the console defaults to iPython, so all the tricks you can use in iPython are available here, and we've chosen here this iPython console. So you can open any files that you want, just raw source code files, and then there's options here to run the code by clicking this green run button, and different versions of run, and then over these blue buttons are different ways to debug the code. So let's go ahead and just start running this debugger. As soon as we do, we can see it drops us onto this first line, and our console turns into this IPDB, as in iPython debugger. And there's several commands that we can use here. If we click the icon and hover over it, it tells us what it's going to do. Run the current line. Okay, run the current line. In this case, it steps over it naturally. And then we can see each time we run the current line, we can see the updated values here that are being computed. And if we go over and look at the variable explorer, we can see the values for the variables as they're created. So if we click on step through, we can see that we're generating these new values as they come up. The button to the right lets you step into a function. So if we go down to this linspace, we can step into it and see the details inside of that code, which we're happy with linspace. We don't really want to do. Let's go ahead and step out of it. Whoops. And we'll just continue over the top, and we can see as we go through what the values for our different variables are. If I double click on it, I can see the whole array, which can be useful along with the local indices that we're using. So that's a convenient thing to do. We have breakpoints just like we saw before. You can do those by double clicking on these line numbers or outside, and that'll set a red dot. We can put one inside again like we saw before, and then we can run here. You can continue the execution until the next breakpoint. Pretty self-explanatory. And we can see the value for our local variable I is 1, and we continue I is 2, I is 3, I is 4, and we get the behavior that we expect. While we're in there, if we want, we can run specific commands. So suppose we want to look at the value of a variable or a product of a variable. We can type, for instance, q1 times q2, and it'll evaluate for us. If we type q1, q2, it'll compute it. If we're not sure about command options, if we hit the question mark, okay, it'll give you a list of commands that we can execute. And a number of these commands are fairly useful. So if we type next, for instance, it'll step for us. So we can type next to step through, or we can hit the buttons at the top. If you're not sure what those things do, you can type help, next, and it'll give you an explanation of what those commands specifically do. So Spyder is a pretty easy, intuitive interface. You just open your code and you can run the code, or you can debug the code. And the main ideas here are that we can set breakpoints, and we can look at the values of variables, and we have a few other commands that we can use locally as we go through. There are, let's look briefly at the iPython notebook. There are commands that are available in iPython, but on our machines they're not working as well as we would like them to be. So let's just go ahead and open up, create a new notebook, and maybe we will we'll just copy and paste that let's just copy and paste that code that we had in there. What do we call it? DBG. Pick your favorite editor. And I'm just going to copy it and paste it in like so. And we can run it, and when we run it, we get some output. Suppose we put something in there like we made a be 0. Okay, so when I make a be 0, then it's going to try to divide by a. That obviously won't work. When I run the cell, it automatically kind of tells me that I've got a problem. A division by 0, and it tells me where it's at. In this case, line 28. If you want to see what line you're on, go and click on the cell, hit escape so that you're not in type mode, and then just hit the L key, and it'll turn on line numbering for you, which is convenient for seeing those. If you want to turn it back off, you just toggle it on off by hitting the L key. So in this case, I can see where it's at. But if an error happens like this, I can also go and enter a debug mode by going to a new cell and typing %debug. And then if I hit enter, then it'll drop me into the location. And I have this little iPDB window that I can enter commands like we did before. So if I hit the L command, it'll list the code in the local area you can type L like 1 to 30, and it'll show a bigger listing of the code so you can see kind of where you're at. You can also enter values like Q1, and it'll tell you the value Q2. I can go TS, and it'll output the values for TS and enter those similar kinds of commands. But we have less functionality so far in terms of setting breakpoints and whatnot within the iPython notebook. Let's go ahead and close out of the notebook. The iPython can also be run, rather than a notebook, you can run iPython from a console. We haven't really done much of this, but I can show you as another example of how you can run a code file. So here it gives me this console. The iPython is nice because it's easier. It's pretty easy to run different kinds of Python scripts. If I type ls, for instance, it'll list the files that are in my current directory. If I type pwd, it'll print the working directory, and I can see that I'm in the C drive. I want to be on my J drive, so I'm going to type cd for connect directory, quote, j colon, end quote, and then if I do pwd, it shows that I'm on my J drive. If I then do like an ls, I can see that I've got a whole bunch of files, quite a mess in there, including this dbg1.py that we've been talking about. If you type edit gdb.py, dbg1.py, it defaults to your favorite editor. In this case, it's not my favorite, a Notepad. Don't save. But I can edit the thing. It's just a file. I can edit it using whatever local text editor that I have. In this case, we'll open it with MacVim and edit the code however you want. You can run the code by typing simply run and then the file name dbg1, and it runs it as I expect. This text at the end, we can change that by going down and changing it to maybe hello, I made it to the end. Then we save the file, and we can run it again. Hit the up arrow keys to run the previous command, and again we get a little bit different output. If we wanted to debug in this mode, we could type run-d for debug, and then when we type the name of the file, dbg1, then we can see it drops us into this debugger, or this ipdb prompt here, and we can enter those commands. And I can't remember what commands, so we hit question mark. It shows me a bunch of commands, and I can hit next, for instance, and it'll step through. Next steps through. If I type L for list, then I can see where I'm at. It's not quite as pretty and user-friendly, but it works pretty much the same. You can set a breakpoint if you type B, and then the line number where you want to set the breakpoint. Let's do 25. Then I set the breakpoint there, and then if I hit C for continue, then it'll run to that breakpoint at 25. I can see the value of my loop variable, I, for instance. If I just hit I is 1, then we'll continue with C, and I is 2, continue. Now I is 3, we can look at Q1. Okay, continue. Now Q1 has a new value, and it's changing. So you can kind of step through your code in the same kind of way. And the basic commands are fairly straightforward. If we do a question mark, the main ones are going to be like next and step and break for a breakpoint. You can clear your breakpoints with clear, and you can issue another of other commands. So this is a quick introduction to both using some different editors and also how to use basic debugging features. And we'll go through this in some more detail again later.